All right, so question 4 is the significance test, and it says the ACL is one of the ligaments that helps stabilize the knee, and surgery is often recommended if the ACL is completely torn, and the recovery time, you may know this, for a torn ACL is pretty long. So they designed this new procedure to help make recovery time a lot faster, and they have 210 patients who need who need surgery to repair the ACL, and they were randomly assigned whether or not they were going to get the standard treatment or this new treatment. Now, Part A says, based on the design of the study, would a statistically significant result allow the medical center to conclude that the new procedure causes a reduction in recovery time compared to the standard? And the answer is yeah, for a couple reasons. I wrote yes, this was a well-designed study since the patients were randomly assigned the treatment. So we should expect similar results for similar patients. Now the other thing is this. Observational studies are really not a great way to imply that there is causation. Really what you want is a study where you are implementing the treatments, and that's what we're doing here. Part B, they give you data, and they tell you, if you just take a look quickly at it, it says the standard procedure, there were 110 people, it took them on average 217 days to recovery, with the standard deviation of 34 days. For the new procedure, 100 people got the new procedure, and it was on average 186 days. That is a good difference. It looks like, is that a big enough difference to say something is going on? Standard deviation, 29 days. So, and here's your sentence again. Do the data provide convincing evidence, right? This is your key that this is going to be a significance test. That those who receive the new procedure will have less recovery time. So, I'm going to write my hypotheses here. I'm going to say mu sub s. Assume that the recovery time, average recovery time, is the same as the new procedure. And what we're looking for, is there evidence that the standard recovery time is greater than the new procedure? Where mu sub s is the true mean recovery time for the standard, and mu sub n is the true mean recovery time for the new. Now I checked my conditions over here. Some things to point out. Patients were randomly assigned treatment, not random sample. Randomly assigned treatments. It's an experiment. 10 times each population is less than all torn ACL patients, therefore they're both independent, and central limit theorem for both, which means the distribution for the differences will be approximately normal. So we're doing a 2-sample t-test for mu sub s minus mu sub n with degrees of freedom. Well, I need degrees of freedom because it's t, but remember, I don't get this until I do it in the calculator, and when I did it in the calculator, I entered all this information, and I got 207.2. Right? I got a t-test statistic that was very large, 7.127, a p-value of, I think it was 8 times 10 to the negative 12th, so it's 11 zeros, I believe, right? Now, remember, what am I using here? I'm using, for the standard, here's the mean, here's the standard deviation, here is the new mean, the new standard deviation, and I'm doing a 2-sample t-test, right? Now, since our p-value of 0.00000, a lot of zeros, 8, is less than alpha equals 0.05, we reject the null. That means we have, in fact, very convincing evidence, since it's such a small p-value, very convincing evidence that the recovery time for the new treatment is shorter than the standard treatment.